Okay, in our first example then, we are looking at the intersection of these two planes. The first one is plane 1, x plus 2y plus 7z equals 4, and plane 2 is x plus 3y minus 3z equals 1. So you'll notice that a lot of these are going to be similar to the strategies we had when we were finding the intersection of two lines, that we're going to first see if we can eliminate some of the possibilities. We're going to check and see if they're parallel, because if they're parallel, then we know that we don't have to go through all the long work. If they're not parallel, then we'll assume that they intersect, and then we'll follow on with some steps. So in this case, we have to look at determining if these are parallel. So for lines, we compare direction vectors, but for planes, we can compare the normals, because even though the normals are perpendicular to the plane, if you have two parallel planes, their normals should be scalar multiples. And again, imagine the tabletop and a piece of paper right above it that is parallel. Imagine that pencil coming out of the perpendicular of the tabletop, and the parallel plane, that same pencil would go through and it'd be perpendicular to the parallel plane. So all we have to do is compare the normals. And since this question is given in scalar form, we can get the normals really quickly. N1 is 1, 2, 7, right from the coefficients. Then N2 is 1, 3, negative 3. If the normals were scalar multiples, then the planes would be parallel. In this particular case, they're not. So therefore, plane 1 is not perpendicular to plane 2. So if we're looking at the three possibilities, we've eliminated the first and the second. If they're not parallel and distinct, they're not parallel and the same, and so that means that they must intersect at a line. So now we have to figure out that line. When we're doing with intersection of lines, we got the answer was a point, and we set the 2 points equal to each other and then solve the system. We're going to do a similar step here. So what we'll do is write it as a system, just like we did before. So x plus 2y plus 7z equals 4, and I'll call that equation 1. And x plus 3y minus 3z equals 1, I'll call that equation 2. Now one very big different thing here is that you'll notice that we have 3 unknowns but only 2 equations. In order to solve a system of 3 unknowns, we need 3 equations. But we only have 2. That means we can only solve part of this. What we're going to do is a strategy that's going to be the same for all of the intersection of 2 planes. We're going to eliminate one of the variables in both equations, eliminate a different variable in both equations, and then we'll let our third variable remain as is. Remember, our answer is going to be an equation of a line, and equations of lines have variables. Think of grade 9, we had 2x plus 3 was an equation of a line. Even the equation of lines we're going to have here are going to have a variable in it. So we're going to eliminate a variable in 2 equations, eliminate a different variable in 2 equations, and let the third variable stay as is. So the strategy is going to be this. We're going to, and we can pick whichever variables, but in this particular example, I'm going to eliminate x. And then over here later on, I'm going to eliminate y. It doesn't matter. You could eliminate z if you wanted, but some people find it easier just to stick to a same pattern. Eliminate x, eliminate y, and then we'll let z stay the same. So let's look at the 2 equations and eliminate x. Well, there's a quick and easy way to eliminate here. You'll notice that the x's already have the same coefficient, 1 and 1. So if I simply subtract these, the x's should eliminate. So I'm going to go 1 minus 2. 1x minus 1x, of course, is 0, and it's gone. It's eliminated. 2x minus 3y is negative 1y. And then 7 minus minus 3 is the same as plus, so it's plus 7z. 4 minus 1 is 3. And we have part of an equation. Now, I'm going to rearrange so that it's just in y equals. So that'll be minus 1y equals 3 minus 10z. But I don't like a minus y, so I'm going to divide everything by negative 1. And be y equals minus 3 plus 10z. I'm going to come back to that in a second. But I have at least part of my answer. We have y equals. We're going to need an x equals, and then later we'll need a z equals, and then it'll look like parametric. Okay, so I eliminated x and solved for y. Now I'm going to go back to the equation 1 and 2, and I'm going to eliminate y. Well, notice I've got 2y and 3y. So I'm going to have to do something to both of those in order to eliminate y. I'm going to take equation 1 and multiply it by 3, and equation 2 and multiply it by 2. My hope here is that by multiplying the first equation by 3, I'll end up with a 6y. And if I multiply equation 2 by 2, I'll also get a 6y. And then I can eliminate. So 1 times 3, that's going to be 3x plus 6y plus 21z equals 12. And I'll renumber this 3. And then 2, equation 2 times 2 is 2x plus 6y minus 6z equals 2. And I'll call that equation 4. I should now be able to subtract. Subtract these two equations, 3 minus 4. And you'll notice, of course, that 6 minus 6 is going to disappear, and I will have eliminated y. But 3x minus 2x is 1x. 21z minus minus 6, that sounds like plus, so it'll be plus 27z. And 12 minus 2 is 10. I now have another equation where x and z, and I'm going to isolate for x. Oops, that'll be 10 minus 27 as it goes to the other side. 27z. And I have now an equation with x equals. The third step, so we eliminated x, eliminate y. The third step is to let z stay the same. And this is the leap of faith here. What we do, and it sounds kind of corny, is our third step is to just say, let z equal k. Now z could equal k or t or whatever, but you'll notice that what I have then is I have expressions for z, it's k. We have an expression for y with a z in it, but we're going to change that to a k. And we'll have an expression for x with a z in it. We'll change that to a k. And we'll then have any parametric equation. So we've got our answer. Therefore, the equation of the line of intersection is this.
The second floor, please take your recycling down.
X equals 10 minus 27, instead of z is 27k. Y equals minus 3 plus 10k. And then z is just k. And that will describe the equation for the line. So recapping, we first looked at it and said, okay, we got to make sure that they're not parallel. So we did that right at the very top. They're not parallel. So since the normals were not scalar multiples, we know that these planes can't be parallel. So then we have our two equations. And our steps then, eliminate x and isolate, eliminate y and isolate, and then let that variable, that last one, in this case z equal k. Like I said, you could eliminate y and z and then let y equal k, or you can eliminate y and z and let x equal k. And that will depend on the question. But a lot of students just like to keep with the same pattern. Eliminate x, eliminate y, let z equal k. And you have your answer.